Imagine a creature so tough it can survive boiling, freezing, crushing pressures, and even the deadly vacuum of outer space. Now imagine scientists using its secrets to transform medicine, space travel, and biotechnology. This isn't science fiction. It's the incredible true story of the tardigrade and how its resilience could inspire tomorrow's technological breakthroughs. The indestructible microbe. Tardigrades, or water bears, are less than a millimeter long and found everywhere from moss in your backyard to the depths of the ocean. While they look cute under a microscope with their pudgy bodies and 8 stumpy legs, tardigrades are the toughest animals on Earth. They have been frozen for decades, boiled in hot springs, crushed by the deep sea, and blasted with radiation, and lived to tell the tale. But the real shock came in 2007 when scientists did the unthinkable. They sent tardigrades into space and exposed them to the full brutality of the cosmos. No air, no water, deadly radiation. Most life would be destroyed in seconds. The tardigrades? Many survived. When they returned to Earth and were rehydrated, they simply woke up and carried on, as if nothing had happened. How? The answer lies in a unique ability called cryptobiosis. When faced with extreme conditions, tardigrades curl up into a shriveled, lifeless ball. In this state, they lose almost all body water, slow their metabolism to near zero, and produce protective molecules that shield their cells and DNA from damage. When conditions improve, they rehydrate and spring back to life. It's this almost magical resilience that has inspired scientists to ask, if tardigrades can survive the impossible, can we learn from them to solve some of our greatest technological challenges? Biostabilization, preserving life without cold. One of the biggest hurdles in medicine is preserving biological materials, organs, vaccines, and blood, outside of expensive cold storage. Every year, thousands of transplant organs are lost because they can't be transported quickly enough. Vaccines spoil in warm climates, making disease prevention harder in developing countries. Tardigrades offer a radical solution. In their ton state, they use a sugar called trehalose to replace water in their cells, locking everything in place and preventing damage. Inspired by this, researchers are developing ways to use trehalose and similar molecules to preserve human cells and tissues at room temperature. Imagine a world where a donated heart can be shipped across continents without ice, arriving fresh and ready for transplant, where vaccines can be delivered to the hottest, most remote villages, saving dozens of lives. Tardigrade-inspired preservation could make this a reality, revolutionizing global health. Radiation protection, shielding astronauts and patients. Space is not just cold and airless, it's filled with deadly radiation. For astronauts planning long journeys to Mars or beyond, radiation exposure is a major risk. Even on Earth, radiation from cancer treatments can damage healthy tissue. Tardigrades survive cosmic radiation thanks to unique proteins, such as D-sub damage suppressor, which physically shields their DNA from harm. Scientists have already inserted the DSUP gene into human cells in the lab, making them much more resistant to radiation. This technology could one day protect astronauts on deep space missions, allowing humanity to venture further into the solar system. It could also improve cancer therapy, enabling higher radiation doses to target tumors while sparing healthy cells. The humble water bear, with its molecular armor, might soon be safeguarding human explorers and patients alike. Cryopreservation, freezing without damage. Cryopreservation, the freezing of biological material for storage and later revival, is a holy grail of medicine and conservation. Today, freezing organs or embryos often leads to ice crystals that shred delicate tissues, but tardigrades, by drying out completely and entering cryptobiosis, avoid this problem. Researchers are now studying how tardigrade proteins and sugars protect cells during extreme dehydration and freezing. If we can replicate this in human tissues, it could make long-term storage of organs, eggs, sperm, or even endangered species possible, with higher survival rates after thawing. The implications are profound. more successful transplants, better fertility treatments, and new hope for saving biodiversity. Drying and rehydration, longer-lasting medicines and foods. Tardigrades don't just survive frozen, they can also dry out for years and then rehydrate, picking up life where they left off. Biotechnologists are borrowing this trick to improve the shelf life of probiotics, pharmaceuticals, and even foods. By mimicking tardigrade stabilization strategies, using tree hellos or similar molecules, companies are developing ways to ship sensitive medicines and beneficial bacteria without refrigeration. This could dramatically reduce costs, improve access, and cut down on waste in global supply chains. Synthetic biology, engineering resilience. In perhaps the most visionary application, scientists are transferring tardigrade genes into other organisms to boost their resilience. Yeast or crops engineered with tardigrade proteins become more resistant to dehydration, radiation, or temperature extremes. Human cells modified with Ds up become harder to kill with X-rays. This new field of synthetic biology offers the potential for crops that survive droughts, microbes that clean up radioactive waste, or materials that withstand harsh environments. The possibilities are as limitless as the imagination. The future tardigrade technology. All of this is still in its early days, but the promise of tardigrade-inspired technology is real. It holds the potential to save lives, protect astronauts, conserve endangered species, and revolutionize industries from medicine to agriculture. It also reminds us of something greater, that the solutions to our biggest challenges may come from the most unexpected places. The tardigrade, a creature too small to see without a microscope, is showing us new ways to endure the impossible, adapt, and thrive. So the next time you look at a drop of water or a patch of moss, remember, the world's toughest survivor might be hiding there, holding the keys to the future of technology in its tiny, indestructible paws. From the vacuum of space to the heart of the lab, the tardigrade is quietly ushering in a new era of resilience. Its survival story is becoming ours, and the best is yet to come.